to go over 7.4 geometric sequences and series. It's kind of a long one. Sorry, I didn't realize that when I assigned it. So as you see, it's long because look at all the vocabulary. A sequence you've known forever, like 1, 2, 3. That's a sequence, even though that's a basic one that you're just adding one. Term of a sequence are these numbers, the values there. So the first term is A1, the second term is A2, and so on and so forth. Usually we say AN, and N just represents any number where it ends. A finite and infinite sequence, you know that goes on forever. Finite will end. Geometric sequence is when we multiply. Multiply and divide are the same thing. Division is just multiplying by the reciprocal. So if I want to divide by 2, I can multiply by half. Common ratio is the number that you multiply by. Explicit formula means what is the 100th term of this sequence with the formula. The recursive formula means that we have to do it over and over and over again. In order to get the 100th term, I need the 99th term. Okay, so you have to do a lot of terms to do the recursive formula. Geometric means is a way to find missing values or in between values. Say I have 2 and then some blanks that we don't know, and then 25, I'm just making one up, so that's geometric means to find those. Then we have this different thing. We have sequences, which are all of these, and then series. Series are basically in the calculator. What a series is we get a sequence, 1, 2, 3, ... but a series is sometimes called the summation. And in the calculator, that's what it's called, and I saw with Desmos, if you type SUM, it will bring it up. Series means 1 plus 2 plus 3, ... Now, we do the summation ones, but there are other series. Geometric series means that you multiply to get the next term, so like 2 times 2, but then you're going to add them as you're multiplying to get the next term. So 2, 4, 6, 8. No, that's not multiplying, that's adding. 2, 4, 8, 16. That's multiplying, but you're adding the total together. And sigma notation, sigma is a Greek letter, and that's the summation. And it's a shortcut to do this geometric series. Okay, that's a lot. So I talked about these. The important part here is A1, A2, A3. Typically, like I said, we say AN. That's the nth term, okay? Domain is 1, 2, 3, all the way to how many terms we have, and the range, thought of the y, are the actual values in the sequence. So if I made up the sequence, let's use the 2, 4, 8, 16, 32. 1, 2, 3, 4, 5. N is 5 because there's 5 terms. A1 is 2. So my domain would be 1, 2, 3, 4, 5 for the 5 terms. And my range would be 2, 4, 8, 16, 32. Okay? On my example right here, the common ratio that it's multiplying by, my ratio is 2. Because I'm multiplying by 2 to get the next term. A geometric sequence is this formula. So this is the explicit formula, which I'm going to put an arrow right there, which means if I want the 100th term, I get my first number, my ratio or my rate, and then in the exponent I do 100 minus 1. N is 100 in this case. Explicit means I could pick any term of the whole thing. And if you notice, it's like the exponential equation where we have our starting number our rate and x, but this we do x minus 1 because we're always starting with 1. That way we get 0, 1, 2, 3. Our first number will be 0 here because 1 minus 1 will be 0. So it's very similar to exponential. It's just n minus 1 or x minus 1 in the exponent. The recursive formula means that I have to get all of them. So on my little example there, 2, 4, 8, 16, if I want the 100th term, I have to go all the way and get the 99th term, because this is how I get 32, and then I multiply 2 and I get 64, and I multiply by 2, and on and on and on. The recursive formula, this is the formula, this is the term, n minus 1, and it stays like that, but you have to tell it what A1 is. You have to tell it where to start. You also have to list what A1 is. So those two parts for recursive. Or else you don't know where to start with this. So you need to tell it where to start and then which term you want. Geometric means are the terms between two non-consecutive terms, and we'll do an example with that to find missing terms. All right. So this one's an easy peasy. We got geometric sequence 2, 6, 15, 30. Is that geometric? Well, it needs to multiply by the same number every time. And the way we find the ratio, this is really simple that you could tell 2 times 3 is 6. If you didn't know, you do 6 divided by 2. 15 divided by 6, 30 divided by 15. Well, this is 2 and this is 2.5. So they are not the same, so it is not geometric. It would have to be the same value every time that you multiply to get the sequence. Example 2, we want the first 6 terms. So -1, -2, -4. Side note, geometric sequences can alternate signs. I could have -1, +2, -4, +8, and then the ratio is a negative. That ratio would be -2. Oops, I'm sorry, I wasn't looking down. Okay, so you can alternate signs, and when you do, your ratio is a negative. The other thing I wanted to tell you was these are all, your book focuses on geometric, which are multiplying. We do have the other type that you did in Algebra 1, arithmetic, not metric. And that's when you add or subtract each time. And that's a common difference, not a common ratio. And it's called difference because you subtract to find the value. But it could be a positive or a negative. And you know, if it's a difference, we could still have a negative, because when we add a negative, that's subtracting. I don't think your book covers those, but we'll do those separately. Okay, so here's this one. The ratio is -4 divided by 2 or -2 divided by 1. Either way, it's a +2. And you could see that multiplies by 2. Find the next 3 terms. So we go -16, -32. The domain is 1, 2, 3, 4, 5, 6. The range is these values. So when you graph it, your domain are those and the range are those values. Notice they are not connected. I drew on that to show the shape, but I shouldn't have drawn on it at all. These are the only points. 1, -1. 2, -2. Nothing in between. They are not connected. So your domain and your range are not connected. Those are the points. Okay. Example 3. Find the nth term. Javier wants to eat less chocolate each day. To achieve this, he starts with 50-gram bar of chocolate, eats half the first day, then half the next, half the third, and so on. How much does, oh, he starts on Monday. What's the mass he will eat on Friday? So describe in your own words, then list questions you may have, or answers to your questions. So we're trying to find mass on Friday. And how many days is that? 5 days of eating. Okay, how will you approach the task? So we know they're going to start, I'm just going to jump into it. We know he's going to start with 50 milligrams. He's going to eat a half, which you could put a half there because it's 50%, right? And it's 1 minus 50%. It's decay because a piece of chocolate's going down. Now we put n minus 1 in the exponent. What formula? There it is. How much chocolate will he have on Friday? So you could do two different things. We could count it down because it's just half. So we have Monday, Tuesday, Wednesday, Thursday, Friday. Or you could use that formula, 50.5 to the 5 minus 1, and put it in the calculator, which I just put mine away. Parentheses are great here. With exponential anything, raise it to the 4th power, and you get 3.125. Sorry. That one's not too bad because it's just 5 days. But that's the equation for it. Oops. I'm sorry. Okay, so remember it is n minus 1 in the exponent, but still we have our starting number, our rate, which is half, and it's decay, so that's less than 1, and n minus 1. All right, find the nth term. So here's the sequence. It's alternating, so I know it's going to be negative. 9 times negative 3 is positive 27, or you could divide it. Write the equation, starting number 3 to 3 minus n. So you could write it like this with the 1 or like this without. Find A8, and this is a different problem. Okay, that was all A. This is B. Find A8 is 5. Find A1. Sorry. A8 is 5. So our n is 8. That's 5. Our rate is 1/2. So A8 is our first term, which we're finding. So I'm going to put a question mark by that. 1/2 is our rate, and 8 minus 1. That's n minus 1. Here's our general formula. So we substitute A8, the 8th term is 5, n minus 1 is 7. So 1/2 to the 7th is 2 to the 7th. I don't know it. 128. Okay, so then I multiply by 128. Multiply by 128. Since that's a fraction, it cancels. And times 5, and I get 640. So my A1 is 640. Now to finish the equation, we write A1, 640, 1/2 to the n minus 1. Example 5. So we have recursive, which we've been doing, or explicit formulas. Explicit formulas, are the ones we've been doing. Recursive means they occur over and over and over. So we have this, which is a recursive formula. Why? How can I tell? There's no exponent. So this is, the nth term is 1/5. N minus 1 is the previous term. Our first number is A5. So since it gave us all this, n is greater than 2. So we're starting with our second term. Write an explicit formula. Well, that's really easy because you could see here it's multiplying by 1/5. So 5, 1/5, n minus 1. Still n is greater than or equal to 2. That's it. Your starting number, your rate, and n minus 1. This is my rate because it shows multiplying by that. The explicit formula, that's it. This one starts with the explicit formula and write a recursive formula. Well, you start with your starting number, A1, and then R is 7 on this. So you need to tell them where to start. So we did there. And then it's 7, always your R, and AN minus 1. So that's the formula. You don't have to change the n minus 1. The n minus 1 just represents the term in the sequence. Okay? It just lets you have a place to plug in. So now if I want the 5th term, I'll show you right here. If I want the 5th term, I need 2/3. No, I start at 2/3. Then I multiply by 7, and I need n minus 1. No, that's the explicit. I'm sorry. If I want the 5th term for this one, I have to do 2/3 times 7. That's the first term. That's the second term. And then 2/3, that answer times 7. So this is A2, A3. Do you see you need to get the previous one? And then this number, so this goes in here. Then this goes in here, this final number. Times 2/3 times 7 would be the 4th one. And then this answer times 2/3 times 7 would be the 5th one. So that n minus 1 represents the term before the one you're looking for. So if I want the 5th term, I need all of the terms before. Geometric means. Find 4 geometric means between 243 and 32. Well, this is going down, so it's decay. Find the total number of terms. Because there are 4 terms between the first and last, there's a total of 6 terms, so n is 6. So we know n is 6. What we do is we set our 6th term, and we call this our first term. We make a baby sequence, okay? So we're going to say 243 is our first term. It's down here. 32 is our 6th term. And A1 is 243. So we use what we know. We know A6, and we know A1, and we know n is 6. We don't know R. So we get this. Now, how do we get the answer? 5th power, we take the 5th root. 5th root of 32 is 2. 5th root of 243 is 3. That's our rate. Now that we have the rate, we could find the missing terms. 243 times 2/3 is 162 times 2/3 times 2 divided by 3, 64.8. No, that's not right. I got that one. Why didn't do 162 times 2 divided by 3, 108. Times 2 divided by 3. I don't think I hit enter, and so was doing PEMDAS. 72 times 2, enter, divided by 3, 48. And I know they're down there, but I want to make sure I got it on the calculator. Okay, so that's how you find missing terms. The other thing, I guess I'll wait on series. So I'll just assign you sequences this time. Okay, so this is the first part of the video. We'll do geometric series maybe on Friday. It's very simple. And your assignment will be on the board or posted on the website. Thank you.